Travel time to work. This is a data problem. The travel time in minutes to work of residents in two cities are recorded below. So I have two lines of data, one for city A and one for city B. My question is there enough evidence to reject that residents in the two cities spend the same amount of time commuting to work? The significance level is 10%. This is a two sample T procedure problem. So let's state this. So this is a two sample T procedure, or I can just call this a T test. Why? Because number one, the population standard deviation or the population variance is unknown. So we have unknown sigma. So that's why we follow a T test, not a Z test. And then how do you know this is a two sample T test, not a match pair? The reason is we have two independent samples. Independent samples. The first one is city A, the second one is city B. What is two independent sample mean? Two independent samples means this pair, 24 and 18, they are not related. So the 24 belongs to one resident, the 18 belongs to another resident. Unlike the match pair test, you cannot subtract the 24 and 18. Another way to interpret this is if you live in city A, then you cannot be in city B. So you give me one number. If you belong to A, then you don't belong to B. All right, so that's why we say they are independent samples. And then since this is a data problem, you will have to input the data first. So to input the data, where do you input the data? We have the screenshots on the right. So you go to stat and then you go to edit. So you go to stat and then you go to edit. So I already input the data. And then in case you don't remember how to clean up an old data, so I put city A in L1 and then city B in L2. So for L3, that is old data from the previous problem. How do I delete that? So all you have to do is you put the cursor on top of L3 and then hit clear and then you hit enter. So now the data is gone. Put the cursor on L3, hit clear and then hit enter. So pause the video, take some time to input city A to L1 and then city B to L2. All right, don't make any mistakes. If you miss one data, then the entire problem is wrong. All right, so after the data is finished, and then where do you go? You go to stat and then you go to test and then you select a two sample T test as what you see on the right hand side of the screen. All right, so we go to stat and then we go to test and then we select a two sample T test. So this time we have data, so I'm going to select data. I put city A in L1 and then city B in L2. So to type L1 you click second 1 and then to type L2 you click second 2. The frequency 1 and 2, keep that in 1, don't change that. And then for the sign not equal, why do we put a not equal? So here is why. Let's read the question one more time. Is there enough evidence to reject that the residents in the two cities spend the same amount of time? I use the word the same. Same means identical. So identical means what? Equal or not equal? Identical, the same means equal, right? Where do you put the equal? We put the equal in H naught. And that's another reason is reject. So when you see the word reject, we put that sign in H naught. So for H naught, we have mu1 equals to mu2, or you can write mu A equals to mu B. And then for HA, so the opposite of equal is not equal. So that will be mu1 not equal to mu2. And then when in the two sample t-test screen, you will have to select the not equal. So since you select a not equal, then this will be a two-sided test. So this is a two-sided test. All right, so you select a not equal, and then the poll is always a no, unless the problem gives you a statement saying that they assume the two population variances are equal. If the problem gives you one sentence saying that they assume the two population variance, you don't need to know what it is. They just assume that they are equal. Then you select a yes. Usually it's a no. All right, so select a no, and then if you click calculate, you will get all the results. If you click draw, you will get a picture. The picture right over here, they will give you the p-value, half on the left, half on the right, because this is a two-sided test, and then the t, the positive t is on the right, the negative t is on the left. All right, and then let's click calculate. So when you click calculate, you get a t, and then you get a p-value, right? So let's write the formula down. So the formula is t equals to, so let me use a different color to give you a better contrast. So the t is equals to, the formula is x1 bar minus x2 bar, and then subtract mu1 minus mu2. Some textbooks don't show you the mu1 minus mu2 because they assume that they are equal. So two numbers are equal, one minus the other must be equals to 0. So that's why they just take this part out. And then divided by s1 squared divided by n1 plus s2 squared divided by n2. Where do we find these numbers? You find this number on the calculator screen. Do you see that on the fourth screen? So you have s1, s2, n1, and n2. Okay, so what is that equal to? Take a look. That is equals to 1.067, 047, right? So that is equals to 1.047. And then what's the p-value? The p-value is equals to 0.3089, right? So the p-value is equals to 0.3088. So we add 1 to the a, so that will be 89, and this is clearly greater than 10% alpha. And then what else do we have? We have degree of freedom. So degree of freedom is approximately equals to 18.27. The degree of freedom, you don't take n minus 1. There is a big formula to calculate this degree of freedom. You have to watch the first video to find out what it is. Usually you don't have to write the formula out because we have technology nowadays. All you have to do is just report the number. Okay, so since p-value is greater than alpha, and then what do we say? When p-value is greater than alpha, then we fail to reject the null hypothesis then. All right, so let's type this up. So since p-value is greater than alpha, then we, what do we do? Then we fail to reject the null hypothesis, right? So since p-value is greater than 10% alpha, then we fail to reject H naught, and then what do? We fail to reject H naught and say that we do not have evidence to show HA is true. So we do not have evidence to prove HA is true. What does that mean? That means we do not have evidence to prove. So we do not have evidence to prove that the average travel time to work between the two cities are not the same. Okay, so this is your conclusion. And then after this, what I'm trying to do is I'm trying to build a confidence interval. So now the t-test, the two-sample t-test is done. So this is the end of the two-sample t-test. What I'm going to do next is I am going to do a confidence interval. So alpha is 10%, so we have a 10% alpha. So therefore, we have to construct a 90% confidence interval. And here is the formula. So we have the point estimate, x1 bar minus x2 bar, and then plus or minus t, alpha divided by 2, degree of freedom, and then s1 squared divided by n1 plus s2 squared divided by n2. Of course, we use the calculator to get that. Oh, by the way, speaking of the graph, when you are doing homework online, most likely they will ask you to give them a graph. So since the HA is not equal, so that is a two-sided, you have half p-value, each piece, one piece on the left and one piece on the right. And then the negative t is on the left, and then the positive t is on the right. And then for the confidence interval, you go to stat, and then you go to test. You have to look for two-sample t interval. So two-sample t interval. I have to get rid of this first. So stat test, two-sample t interval. And then we have a data. So data, so we have to input, I have to input L1. I don't think you need to type anything except you have to make sure the confidence level is 90%. So let me type L1. Okay. second one, and then second two, and then frequency, don't change that, and then the C level is 0.90, and then no pole. So now we calculate. So you have -4 and +17. So this one, they round this up for me. So that is a -4.259, and then 17.259. In my class, I ask students to do two things. Number one is you explain the confidence interval. Explain these two numbers for me. So let's type it up. So how do you explain a confidence interval? Explain the confidence interval. To explain, the correct language is we are 90% confident that the average difference of travel time, the off goes over there, of travel time to work between both cities falls between -4.3, you can round a little bit, so -4.3 and +13.7 minutes. If you have two positive, then you use two positive, right? If you have two negatives, it is okay to remove the negative. But if you have one positive and one negative, do not remove any sign. This is very important. That gives me a very good signal when you have a negative and positive. I will explain why in a minute. So 7.3 minutes. So this is called explain. How about verify? I'm trying to verify. How do you give me a verification? So here is how. First of all, you recall the H naught. So H naught is mu1 equals to mu2, right? So that means mu1 minus mu2 is equals to 0. Write this out. Simple math. So let's say 2 is equals to 2. Then 2 minus 2 is equals to 0. And then we will have to use this 0 to make a verification. Now, answer a question for me. Is 0 between these two numbers, between -4 and +17? The answer is yes, right? So this equals to 0 is inside the confidence interval. What is the confidence interval for? The confidence interval saying that the truth is between those two numbers, and you have equals to 0, and this 0 is between those two numbers. That means your H naught can be truth, right? You are saying that the truth is between -4 and 17, so now your H naught has a 0, and this 0 is between -4 and 17. That means the H naught you just wrote, that can be the truth. So this is inside the confidence interval. That means H naught can be true. And therefore, you fail to reject H naught. You fail to reject H naught. Now, check it out. Using the p-value, you fail to reject H naught. And then using the confidence interval, you fail to reject H naught as well. So that means I just use the confidence interval to fail to reject H naught. So there are two ways to fail to reject the H naught, or to make a conclusion. First is using p-value, which is what we just did. And then the second way to do it is using confidence interval. I would like to use both. So first of all, I use a p-value to draw a conclusion. And then I build a confidence interval to support the conclusion that I just wrote. So I call this verification. Okay, now let me go back to that question. For confidence interval, where you see a negative and positive, this is a very clear sign that the conclusion is failed to reject. So for H naught, right? So for H naught, sometimes you have an equal, sometimes you have a less than or equal to, sometimes you have a greater than or equal to. When you have a negative and a positive, this must be inside. The equal will be inside. The less than means negative, right? The greater than means positive. So when you have a negative and a positive, it doesn't matter what sign you use for H naught, it is always inside the confidence interval. That means the conclusion is always a fail to reject. So that's why when you have a negative and positive in a two sample problem, open up your eyes. This must be a fail to reject problem. And then for the explanation, for negative and positive, this is a big trouble. Do you see that I wrote an explanation? This explanation pretty much makes no sense. Do you know why? So here, when you have see negative and positive in confidence interval, it must be a fail to reject H naught because the interval includes negative, positive, and zero. So this kind of estimation tells you nothing. So for example, I wrote two numbers on a piece of paper. So let's say unknown number 1 and unknown number 2. I am asking you to make a guess. Here, let me give you some hint. Number 1 is they are equal. Number 2 is 1 is less greater than number 2. Number 3 is number 1 is less than number 2. Now, answer a question for me. Can they be all true simultaneously? No. Right? So when you compare two numbers, either one of these is true. Either they are equal, one is greater than the other, or one is less than the other. When you have a negative and positive in a confidence interval, that means you are saying they are all true, which is no sense, makes nonsense, right? So that's why, remember, when you see negative and positive in confidence interval, open up your eyes. There is a big problem going on. Okay, so that is the end of this problem. If you think my instruction is helpful and clear, give me a like, share, and subscribe, and I will see you all in the next example. Signing out.